Hey, if I can touch your network, I can own your network. The simple fact is that most folks figure that the firewall keeps out all the bad guys, all the folks out there on the internet who are trying to do evil things to your computer network come through the firewall. The fact of the matter is, that's not the case. Most vulnerabilities and most exposures to malicious software are a result of activities on the trusted side of the firewall. That side of the firewall where employees plug in computers that have been down at Starbucks on the wireless and are now infected with all kinds of malware and adware and other types of viruses that come in and they plug it into your network, and voila, we're now affecting everybody else in the office. Now, sometimes there's even bad guys who come into the office and plug into an available computer jack or get on your wireless, and they do bad things. For example, let's assume Bob here decides to come into the office and plug into an available jack in your network, and Bob decides to bring up his own DHCP server. You don't have to be a rocket scientist or a network engineer to know that the DHCP server hands out information to all the computers that plug into the network that says, hey, when you want to go to the internet, go here. Bob, however, decides to create a rogue DHCP server and tell everybody that when you want to go to the internet, you come to Bob's computer, and Bob will then send you to the internet. Unfortunately, while Bob is sending you to the internet, he's looking at everything that you type, every username, every password, and he's making a wonderful little list to steal your identity later, and all because you made it possible for him to plug into your network. So what's the body to do? Network access control is a concept in which we say our network is nailed down. Nobody can plug anything in or jump on our wireless unless we know who they are, and not only who they are, but what hardware they're using. And when they bring up a computer, we want to check that computer to see if it has the requisite virus protection, that it has the requisite network access control software. We want to inspect that computer and make sure that it can, in fact, work on our network without causing trouble. Once we make that determination, then we want to know who's using the computer. Is it Bob, or is it some trusted employee who should have access to some of the corporate resources, but not other resources? We can do this, and the way we do this is by creating an identity service engine, which, when someone turns on a computer or plugs in, they can't go anywhere. This port is literally shut down. Maybe the only thing they can do is bring up a browser. And if they bring up a browser, they are redirected to the identity service engine, which, working with Active Directory, will establish the credentials for that user. And it will allow that user certain privileges. And it will reconfigure this switch port to the proper VLAN, for example, to enable voice and data communication, or the VLAN for staff, or the VLAN for guests, or the VLAN for executives. All of the profiles that we would like to apply to a particular user are done through the implementation of an identity service engine. So don't leave your switch ports available for anybody to plug in a rogue DHCP server. Don't allow anybody that's not authenticated to use your computer network. And by the way, this applies inside the company or on the other side of the firewall. If you're extending your network through VPN technology to remote branch offices, or you allow guys to log in from Starbucks to check their email, make sure you run them through the internet, the identity service engine, and let's establish their profiles, know who they are, and know what resources they are allowed to connect to.